Hello, my name is Oleg Slazitsky. I'm a software engineer at AWS. I'm working on the networking team. And today we'll take a quick deep dive into multiplayer components and the basic elements involved in that. So let's get started. So first, I assume you already know about O3DE components. But by default, components are not networked at all. It's something we have to do something additional. For that, we've developed multiplayer gem. And you can take a look at some of the basic existing examples inside multiplayer sample project. And my slide contains the GitHub links for that. So what are the actual basic elements of multiplayer component? There's actually 4 elements when I take a look. So first we're going to start with the XML file, which kind of defines the schema of a component, which will then use CMake code-generator to actually create some basic classes for us, and we will derive from those to create our own game logic. So let me quickly jump to my Visual Studio Code, which has my local examples. So here's one of the basic components we have, which is the network transfer component, which synchronizes your position in the world. And notice here, this is where you define the name of the component.
Oh,
does it not switch? All right, okay.
There you go.
There you go.
You're good.
All right. So again, here we have the name of the component, network transfer component. And in order to define a property that you want to synchronize between server and clients, you would add network properties. And here, for example, we have rotation, translation, whatnot. So my example will be, take a look at the parent entity, for example. So here just we provide the name, and then for that we'll get a code-generated example. So let's see. If we jump back to a multiplayer gem, inside AutoGen files, this is where you can see the XML file. Now the code generator one example is inside a build folder. So let's go outside. Now I've chosen to place my build folder on the O3DE engine, and see if we can keep drilling into external. We're going to go multiplayer gem, code. Now this lives outside of your general source because this is not a custom build folder. But here you can scroll down and you will see network trans component header file. Now this is code-generated code which provides a lot of logic for you. You don't generally need to worry too much about that, but it does give you some good starting examples in the beginning where you can see the how you would derive from this component. So this class provides network component base class, and you would derive your custom from that. So let's take a look at an example. For example, we were looking at the parent entity ID previously in XML file. Let's jump back for a moment. We had network component. We had the parent ID here. So if we go back there. So here's the code-generated code and class that you can use to get the entity ID on the client. For example, this is you would get access to. Now additionally, oftentimes on a client, let's go back to the slide for a moment. So what is a network property? It's a property which you would synchronize between its client and the server, server to client. And this is you would define the type of it, C++, and the name of it, and so on. And inside your component later, you will be able to get it using various calls, such as get translation, get set translation. And notice in this case, the get and set starts from a name you give it. You just capitalize the T to make it nicer. So let's jump back to the code. So this, for example, this is your get parent ID, whatnot. Now let's go back to the code that actually derives from it. For example, this is, go into the include file to get started. Here you can see the components. And here's network component base. It derives from the base to get our own actual component. So one of the things you want to do in a client is listen for a change in a property. In this case, you would do sign up call for on parent changed. And this involves using AZ events. You can find documentation on how to use AZ event outside on the O3DE.org website. There's a quick introduction. We can go to the source file for network component. Inside Activate, this is when we sign up to the parent ID changes using add event. This is, again, code-gen as well. So if we go back to a code-gen base file, you can see this add event right here. And this is how you sign up on the client to listen for a change. So what is one of the things you will notice that the code-gen creates is there's a component base and a controller base. So let's take a look at actually what that means. So again, going back to the code-gen example. Let me see. So here we have a controller base right here. Controller base is a server-side object which actually has some controlling options over your properties. It's generally only the controller base can set a network field, and the client has to listen for them. So in a way, you can think component base is just something that exists on both client and the server, but the server also has a controller. So if you wish to set a property such as parent ID, you have to do it on the controller side, on the server side. As an example, let's jump back to network transfer component. So this is, let's go down a bit. We will see here we have the controller. An example, this is we can set rotation. Notice it happens on the controller side. On the client side, this is not possible because client side just mimics. It doesn't have the actual controller to set network properties, which will be replicated for you as well. So I was talking about briefly before how you would listen to it. What we do is that if you declare a network property called translation, we would code-generate an add event method for you, which you would sign up for listeners to listen for that change. And you do that generally you do that on the client side. So if you go back to network transfer component, specific on activate call, this is you would see add event call. And this parent change event handler, you provide a lambda to respond to it, which you can see right here. And next up, the next feature, in the last feature we'll talk about for multi-pair components is remote procedure calls. In general networking, you want to either synchronize a field across, or you want to send actual specific messages. So these are generally called remote procedure call networking fields. And these are supported in XML schema for a component. So let's take a look at one example. In this case, I will jump to a network rigid body component. So let's see. Again, we go into multiplayer gem. Going into the source section, auto-gen. And so you can see the schema for the network rigid body component, which is a physical component. In this case, we're synchronizing a physical object. You will notice it has an XML element called remote procedure. The name said apply impulse. And this here, we would describe the parameters you would send for this particular procedure method. So again, if we take a look, again, this is as we've seen before, components have a component base, and we have a controller as well. So in this particular case, you can see the handle is something you can add to a handler or PC on the server. And you can see the same impulse world point. So if we go quickly, take a note of this impulse point and go back to XML, we will see exactly those things defined in XML structure. Which are right here, impulse and world point. And there's a lot of stuff happening behind the scenes that we provide networking logic for, so you can easily synchronize networking fields and remote procedure this way. And this way you can merge O3DE components together with networking features. And here provide extra links so you can take a look at, if you want to know more, you can figure out tutorial. So let me show you the website where it's available. On O3DE.org, you can go to tutorial sections, and here we'll see your first networking component. Now, in this brief talk, I described the existing component, but you can take a look how to create a new component completely from scratch, and that will be the example right here. And next, I will hand it over to Gene Walters, who will describe how to use scripting to create way more involved gaming features. Thank you.
Cool. Test, test. 1, 2, 1, 2. All right. Hey, I'm Gene Walters. I'm a software engineer at AWS, and I wanted to cover multiplayer scripting today. Yeah, so, ooh, video not playing? No? Oh, no. Okay. Let me play a video for you guys. One second, a little technical difficulty here. No audio, no. Let's see. Oh, well, there should have been a video playing. Maybe I'm just really laggy, but anyways, I could describe what's happening here. So my main mission for this talk was to help you create a multiplayer minigame in 10 minutes. So using the multiplayer gem in script canvas, what we'll have is, I don't know if you can see, but there's like a red box with a sphere behind it. That sphere is being controlled all through network scripting. And we can drive that sphere around, drive it around the world and interact with rigid bodies, all while keeping the network in sync. Okay, so there are some prerequisites before getting started. Today, I will be working in the multiplayer sample project, which already has the multiplayer gem enabled. There's some setup to this, so you'll also want to make sure that your project has the multiplayer gem enabled. Our gameplay logic will all be scripted, right? So if you haven't already, you'll want to be somewhat familiar with visual scripting and O3DE's script canvas system. Yeah, so while we won't have to write any C++ code by hand, we will be using multiplayer auto components, which generates code for us, so we'll still need to compile. And also, I've made some input binding files already. Input binding, if you don't know already, lets you bind keys and joystick events such as a mouse being pressed or an axis being moved to a gameplay event. And last of all, we'll be using physics components. So if you're not familiar with like rigid bodies, colliders, or character controllers, you want to check out the physics gem. And yeah, at this point, if you don't feel ready to dive in, I've included more information on where to learn about these topics at the end of the talk. All right. So as Olex just went over, let's start by making a multiplayer auto component that our player entity will use for creating, sending, and processing input across the network. I think this is really cool because you don't actually have to write any code. We just fill out this XML file. So I've already created this XML file under my project's gem code source autogen folder, and I've called it simple script player component. This is the namespace. For me, this multiplayer sample, because this is the project I'm in, you'll make this whatever your project is. And leave the overrides as false here. Overrides are only needed when you want to extend functionality of the auto component in code, C++, which we're only scripting today, so you won't need this. This is a component relation. So what we're saying here is we're requiring that anyone that adds this new component to their entity will also need a network character component. And the network character component has this really handy try move with velocity helper function that we're going to be using. And perhaps the most important piece of our multiplayer auto components are the network inputs. So network inputs allow the autonomous player to create input and send it across the network to the authoritative server. The multiplayer gem will ensure both the player and the server process the inputs in such a way that the network simulation stays in sync. So for this demo, I want to control the player using O3DE, so I think it makes sense to send input for moving forward, backward, and left and right. And I'll store these in a float, so, between -1 and 1. And at the very end there, don't forget to set expose to script to true, because we're going to be using this in script. So now that we've created the simple script player component, auto component, you'll need to recompile the project, and O3DE's AutoGen system will turn this XML into a gameplay component. I've already built, so let's head over to the editor. Here I have a new level opened up, and we'll get started and create our multiplayer prefab. So I'm creating a new entity, adding a component, and the add component menu should automatically have our new auto component in here somewhere. So there, so searching, and there it is. We'll add it. Now, the simple script player component has some requirements. There's 3 here. So the first one, because our auto component contains network inputs, the engine will automatically figure out that we need the local prediction player input component. Second in the list there is the network binding component. This is a network entity, and so all network entities use the network binding component. And then remember that component relation we added in the XML. There it is at the last one there, network character component. And we're going to use that component for its very convenient try move with velocity helper method. Network character component has some requirements of its own. So it needs a network transform component. This should make some sense, right? If we're going to want to move the player around, it's going to need a network transform component. And the network character component will also require the standard physics character component, or character controller component. Great. All right. So at this point, we've added all the components required by the network. Let's add a mesh so we can see our sphere and start scripting. So adding a mesh. Now, assigned it. Now we can see our player. It's looking better there. And we'll also add just a standard input component. Like I said before, I created a simple script player input binding for sending keyboard events. This will help our script pick up with what we put down. All right, finally, the last component we'll add will be the script canvas component. I've already created one called simplescriptplayer.scriptcanvas. This will be the multiplayer script for controlling the player. I'll open it up in just a second, but first, let's save our player to a prefab, right? The multiplayer server will automatically spawn the player prefab anytime a new player connects. The default location is set to prefabs/player.prefab. You can save the network prefab to any location. Just remember to update the console variable SV_default player spawn asset, as this is where the server looks before spawning a new player. All right, I've opened up script canvas, and now we're in our simple script player graph. This is the standard input handling. So the input handler node will receive the keyboard inputs. And I'll store these variables forward, back, and left, right. So let's go up to our node palette. If you search the node palette for the name of our new multiplayer component, you'll see that the code gen automatically created the script events for it. So that's pretty cool, I think. We'll be using a few of these. All right. So in order to keep the network simulation in sync, we won't be moving the player like as soon as you get keyboard input. Instead, we'll wait for the multiplayer gem to send us the create input and process input events. Create input will only be called for autonomous players. This is where we decide what inputs actually need to be sent over the network this frame. I'll use our simple script player components create from values node and pass in the forward, back, and left, right variables from earlier. And this create input event expects a result. So we'll pass in the newly created network input back into the create input node. As far as sending input across the network from player to the server, that's all that's required. 2 nodes. All right, I think that's pretty cool. So after creating the outgoing network input, next we'll handle processing the incoming network input. The process input event allows us to take the input that's been given to us over the network and apply it to actually move the player. This event will only be triggered for the authoritative server and the autonomous player. Here we'll use the standard extract properties node to access our forward, back, left, right input. I'm storing this into a script variable called net forward, back, and net left, right. From the network input values, we create a velocity vector and then move using that velocity via the network characters try move with velocity event. Okay, don't forget to save the graph. And at this point, if you launch a server and a game, you'll be able to see your player moving around. And videos aren't playing for me. I'm so sorry. But yeah, so here you would see the 2 spheres moving around. And then, like in the beginning, remember we saw some boxes and they were lighting up red whenever you hit it. So to make the demo a little more interesting, I added some rigid bodies to the level and set them up to change color whenever a player bumps into them. So there's the rigid body component, the network rigid body component. All right, and I'll bring up the video. See if I could just find that for y'all. I think if I turned off screen extension. Let's see. Turn off duplicate? Okay. Yeah, there you go. So that's it. Once you do that, get your 2 little players moving around, network stays in sync. Jump back into presentation mode. Oh, not the beginning. Anyways, that was the last slide there. Here's some more information. Thank you for watching. There's some more information. Go to O3DE.org to check out more about multiplayer, script canvas, network inputs, and VisX. Thank you.